Friday, January 12, 2024. 2JZ billet block. It's been built, clearly, obviously. And why it's here? Why it's here? I don't know if it's okay if I can say all the story what's happening. I'm not gonna say anything actually. It's not my business. I don't know. I know the story, but no need to say anything. Okay? Why it's here? I need to strip off completely the engine, measure the crankshaft, the journals of the crankshaft for the mains, for the connecting rods itself, the piston, cylinders, piston ring, do all the job actually, alright? And see that it's okay and doesn't have any problem. It never ran the engine, it never fire up. They just put it together and they send it to me here. Okay? So, before I continue, before I take it apart, what I'm gonna do? I'm gonna read the camshafts when they're opening and when they're closing, to write down on the paper, because I wanna see how they make it, in which degrees they put it exactly, for a peace of mind. And then they're gonna send me the paper for the camshafts, where they're supposed to be placed, the camshafts, to be everybody happy. Now, that's how I have received the engine. I haven't touched at all. Even the engine stand doesn't belong to us. I received the engine with this stand, and as you can see. All right, there is a plexiglass here for the intake that I need to take it out. There is these rags here on the spark plugs. They told me that the cylinder head, it's fine, no need anything. Here, it's missing one fitting. From here, it's passing a coolant. This is important to be here, the fitting. You know, if you make the mistake and you block that one, you overheat the number 6 and number 5 cylinder, the last cylinders. So here I need to have a fitting, an AN fitting, as big as possible, if you're asking me. And you need to close the circuit for the coolant. It depends in which country it's running. It doesn't matter if it's a billet block or if it's a cast iron block, the stock block or whatever. You need to have this. You cannot block it, and obviously you're not gonna keep it like that. Usually they're welding here an AN, like I said, fitting, and it comes here up. But you can tap it actually, you can thread it, and you can put the stainless steel with some blue Loctite, and you can stay there forever. Yeah, but it's okay. Usually they're doing it with aluminum. They're welding one aluminum fitting there. It's a little bit more sensitive and you have to be careful. Now, it's getting two-way thermostat here. Yeah, this to don't have fluctuation on the temperatures, to don't cool fast, to don't be like, let us say, the single-way thermostat. That's why you have this one. But I don't know if it's smart to keep this function on a racing application, on a dragster application. Okay, this I'm gonna ask the owner. I'm gonna talk to the owner, because for the cooling system, you can connect it with so many ways. It depends the heat transfer that you have. It depends the ambient temperature. It depends what kind of radiator you have. Sometimes you might not have enough space, or sometimes you might have an intercooler in front. You might not have correct airflow, and so on. All right. So that's what I'm gonna do. Let me get the wheel degree micrometer and start writing some things down. Okay. This is not gonna be able to come out because why? Because it's touching. Yes, because of this one. Because of this bracket. So I don't want to bend it. Yeah. If you remove the upper radiator pipe here, yeah, it might be able to come out by turning. Yeah, okay, just drop in the ocean. I might remove first this pipe here, then remove this one. So when I'm gonna rotate, to don't have, it's not a big deal, it's light, it's just don't rubbing the belt on this cover. That's my point. Okay, that's it. Let's start working on it. Yeah. Just for your information, I'm putting everything on the video, like all the small details. I removed now from here the tensioner. None of the bolts was torqued down. Okay, I'm just saying, it's not, you know. Here, these two bolts, they're not torqued down. Okay, this has correct length, the threads that they're entering on the cylinder head, but this up, it's not the ideal bolt to put on, the bolt, sorry. You see, it's just engaging, I don't know, 2 threads only. So I'm not gonna choose this bolt for this. Then, I guess it does have a gasket. Yeah, it does have a gasket, it does have a silicone, it does have nothing. Yep. Here they put a silicone. The O-ring doesn't look new to me. And there is one mark here on the cylinder head. When I make it up, it hit here. Alright, just give me a break. There's no problem at all. I didn't even scratch it. Alright, so the long one was down here. The short one was up here. And now you can see the difference. You will not gonna choose this bolt here. You're gonna choose a bolt same length like the other one, down. It's supposed to have enough threads inside. Yes, it does. It has even longer. Then you have here this mark, this dent. And when you have this kind of things, it's a good thing to file it, to don't keep the plate outside, to don't have any headache in the future. Ah, I saw also another one thing here back. Here back, this is a plug, okay, like this one. It's like a ball bearing, but it's press fit inside. Here, it's been, they dented. It's supposed to don't be like that. Cylinder head here, it's supposed to be like this, not like this. Okay, and it's supposed to have also another one here, because this is how they're drilling it from the factory. They're drilling like this, they're drilling like that. This is an oil gallery to supply oil. Another one thing here for the HGR that's communicate with this hole here inside, you can put a fitting, thread it, make a fitting with one block like this one, smaller than this, not need so big. You can have it as a reference for the back pressure, to have it here. You know, you can unplug it, put the pipe, one pressure sensor, it will be far away, don't get burned, and then you can have idea what's happening between the valve and the turbine wheel. It's nice, it's not bad. Okay, so you get the picture, step by step. Whatever I see and I don't like it, I'm putting on the video, like any other time. Let's move on. And I'm getting the wheel degree. I'm trying now to put it on, you know, to start degree the camshaft, to see to get the numbers actually. Alright, and what they bring me, they brought me the aluminum piece for the intake manifold. Okay, I said don't bother me with this engine. Okay, we start nice. Let me pause now this one to finish the intake manifold for the C-Class outside, the 204. I have it over there, and then continue with the engine. Wish me luck, don't mix up the videos. I might mix it up and you're gonna see the intake manifold with the billet 2JZ. Lovely. Okay, finish with the intake manifold for the C-Class. You see Mr. Romer there? I have no clue what he's doing, yeah? Back to the 2JZ. Now, let's get the stopper. This is stopping the piston to find the top dead center. Need to, where I'm pointing, I don't know where I'm pointing. I need to fix something on that to hold it. What I'm gonna do, I'm gonna use this stopper to stop the piston. Then I'm gonna go front and back, and then I'm gonna zero it out. There you go. Come on, what, it's not clean the threads or what? Let me have a look, 1 second. Don't make any disaster here, any explosion. Okay, now we have 40 after top dead center. Counterclockwise I use the wheel degree. And clockwise it will gonna stop. It will gonna stop me at 40 before top dead center. There it's stopping. So I have 40 degrees before top dead center, and counterclockwise I have 40 degrees before top dead center. What is it? Before top dead center is here, 40 degrees before top dead center, and 40 degrees after top dead center when I'm going counterclockwise. So my zero mark here, it's the top dead center. Okay, let's do it. Let's remove the stopper and continue. And now this one, that's the true top dead center. Yeah, just make one dot on the center of the piston, but it's not important. It's not even dot. We're gonna see that later when I open it. What has inside, I don't get it, but yeah. Okay, let me get the dial indicator to start get some measurements. All right, to see the degrees. Keep it as this. I torque it down the damper pulley, the bolts for the crankshaft, the main. Yeah, and now from now on only clockwise, not counterclockwise. Counterclockwise I did it only to find the top dead center. Now only clockwise to don't compress the tensioner. I'm recording. All right, follow me here. We have here, put here, it's 100 millimeter, a little bit less than 100 millimeter, it's fine, it's acceptable. And here we are top dead center, all right? I'm taking the exhaust load,
camshaft,
all right? Exhaust camshaft, yeah. So, now, at 1 millimeter lift, point down the micrometer, here. Let's go at 1 millimeter lift. It was a little bit past the zero, it was there. Yeah, okay. So what do we have here? We have 41 degrees before bottom dead center. Okay? You get it?
Yeah.
Come close. See. Don't touch anything here. 41 degrees before bottom dead center. What I have right here, come here. Exhaust valve opens at 1 millimeter lift. 41 degrees before bottom dead center. Correct?
Correct.
Let's move on. Now, the lift for the exhaust valve, it's 10.06 millimeters. I highlighted here. Let's find it now. It moves 1, all right? 2 millimeters, 3, 4, 5, 6, 7, 8, 9. Come from there. Wait, no, stay there. Stay there. I'm gonna, okay. 10. Now, if I move it more, you see it's 10.06 millimeters the lift, okay? And you see here, it's at 105, the center line. Okay, all right, I wrote down 101. Now, where I found 101, in any case, skip this one. Let's go 1 millimeter before closing the valve. A second, shift it. No, it's okay. Stay there. All right. Now, there, it's 1 millimeter before it closed the valve. And here we have almost 17 degrees after top dead center. Okay? Come here. Exhaust valve closes at 1 millimeter lift, 17 degrees after top dead center. That's what we have there, right?
Yep.
That's what we have. After top dead center, 17 degrees almost. Let's do it again. Put there. You see, it comes again.
And yeah.
Yeah, all right. It's fine. Let's do that again, another one time. All right, let's spin it. All right. Now, Let's go again at 1 millimeter. All right, and we are 41 degrees before bottom dead center. That's the key. 41 before bottom dead center. We are going to the 10.06 millimeters. Okay. It's supposed to be there. It's supposed to be there because now you see it's 101.
Yeah, it's 101 now. 101.
101. Now if I move it, you're gonna start closing the valve. You see?
Yeah.
All right. And then we have, keep it there, keep it there. Keep it there on the indicator. Okay. So now 17 degrees after top dead center. There, 17 degrees after top dead center. At 1 millimeter lift, it starts closing the valve. All right. And if I turn it again now to go to the top dead center, let's go to top dead center. 1 second, because I have to go now to do the same thing on the intake. All right, that's top dead center. We have almost 100 millimeter till the 0 point. And what do we have here? Exhaust valve lift, the specific one, the specific lobe.
Yeah.
The specific lobe has 10.06 millimeters lift. The exhaust valve opens 41 degrees before bottom dead center. Center line 101 before top dead center. Exhaust valve closes at 1 millimeter lift, 17 degrees after top dead center. Now give it to me here. I put it here. I put when it's opening the exhaust valve, when it's closed the exhaust valve. Okay. And it says to me that exhaust duration is 238 degrees. I don't have to calculate. And exhaust lobe center 102 degrees. Lobe separation, okay. Don't pay attention on the intake because I haven't measured yet the intake. The intake, it's the data what had there, all right. Now, let's continue. Let's do that on the intake lobe to read the camshaft. So by having this data, I'm gonna know exactly where they degree the camshaft and when they bring me the specs to see from there. Another one thing that I need to do is to see how much clearance, how much I can move the gear to see how much room I have between the valve and the piston to don't have any contact. How much I can go advance or retard to see what's going on. Continue. All right, let's have a look at the intake. I have done this 4 or 5 times. I don't even remember how many times, because some of you're gonna say, what is this, what you have done? As soon as it's not spring loaded and it's solid and it's repeatable, I'm happy. Each time that I'm doing it, I'm resetting it. I'm removing from the zero and I have to zero it out again, all this thing what you see, and I repeat again and again. All right, now 4 or 5 times till now, the same thing also for the exhaust. Classic like any other time. All right, now, what do we have? Intake valve opens at 1 millimeter lift 9 degrees after top dead center. Okay. Center line at 127 degrees after top dead center, 127. I was expecting to see something like 107, and I was expecting to see something like 11 degrees before top dead center. Yeah. And intake valve closes at 1 millimeter lift 67 degrees after bottom dead center. Okay. Now, 10.06 millimeter lift for the intake valve and for the exhaust valve. All right. Center line, I found it 127, and what we have here, we have, it's -9 because before top dead center. So if I put 9 degrees before top dead center, I'm not gonna be right. I have to write minus. You can see here, -9 degrees before top dead center, you see? And it's after. Yeah, that's the point. 967 when it's closing, and it's giving to me intake duration 238, exhaust duration 238, okay. Intake lobe center 128, I found 127, all right. Yeah, you can give me half degree plus minus, okay. Give me a break. Now, I want to see the specs for the camshafts. All right, I'm gonna write down in a paper to have this data. And now, since I know the camshafts, when it's supposed to be, how it's been degreed on the specific engine, yeah, I can see how much I can play, right? I can see how much I can play. This is full at the end. It's not worth it to change the teeth and then it might not. Yeah, okay, it is what it is. You might play with the teeth and then adjustment, you know. Yeah. All right, never mind that this is not the time. I just want to see, now we're gonna bring the camera. I just want to see how much distance they have the valves, because now it's a good chance. Why? Because there is the head gasket, that with this head gasket you're gonna run this engine. It's been everything bolted down. There is no dummy gasket, there's no old gasket that I open it and I close by again. So it's very good chance to see how much room we have, you know, how many degrees before we touch the valve, how much I can go maximum and minimum. Because after that you can't play. It depends where you want, where you want the torque, where you want to have a horsepower. Example, you know, you can shift the power band. It depends the application, it depends the transmission, the gear ratio, it depends so many things. It depends even the drag that has the car. It's different if you have, let us say, a good aerodynamic car, and different to have a curtain, a parachute, you know, and trying to win the wind, the air. I hope that you understand what I'm saying. Let me remove, no, don't remove it. Why? Why to remove it? Yeah, let me bring the camera. It doesn't make any sense to check the intake because I believe that's wrong. It's not right. Even that it's on the limit, that means you can fix the teeth. I want to see the paper of these camshafts where it's supposed to be. I just have a look here on the exhaust to see how much space we have, and as it is right now, there is plenty of space. You can put wherever you want. It will not gonna touch. There, what you see from here till this is the cut relief on the piston, and that's the valve here. Plenty of space. I'm gonna show you. Okay, that's the valve here, and this is when it's open, and now it finishes the gear. Oh, with these pistons there is plenty of space. I mean, if you have a valve contact to the piston, that means either you have too many RPMs or you have too much boost, and not on the exhaust. On the exhaust, the back pressure. It depends the back pressure that you create inside the manifold. From the intake I'm talking about. All right, let me remove everything. And then, like I said, I put this on a paper, I write on a paper. If you're wondering what these numbers, this is 41 degrees before bottom dead center to go to the center line to the maximum lift of the lobe. At 101 before top dead center, need 120 degrees. That's one lobe. That means it's symmetrical, it's almost symmetrical. All right, that means when you have the camshaft lobe, it's from here to here and from here to here. Okay, and then from the center line to 1 millimeter close the exhaust valve, the lobe, need 118 degrees. And for the intake, yeah, 118 degrees to reach on the center line, and from the center line to the closing point, 120 degrees. All right, now, yeah, I write everything down. I need the paper for the camshafts, and I have to continue stripping off the engine. Let me tighten also this gear. I write also in which mark it was, just in case. Not something crazy. I'm not torquing it down for final, obviously. Usually with these gears, even if you torque it down, let us say 5 Newton meters, usually it's more than enough, it doesn't slip. I have to see the torque spec, supposed to be something like 10 Newton meters, 15 Newton meters, I don't remember exactly. I'm gonna check it. In any case, yeah, let's move on. All right, camshafts, cam followers, the caps here up, out. All right, it's in order here. Exhaust intake, and these are the cam follower. It's not hydraulic. It's normal pockets that you grind it inside to fix the clearance. It's in order because if you mix up all this, then you have to find out which one goes where. You have with one filler cage all day, maybe two. This way has masking tape. I don't get it. Aha. And I was wondering, I saw that before. I said, why to have a masking tape the cylinder head here? This here has a dent, and here has a crack. That's why there was a masking tape here. Who put the masking tape here? They put it to hide it or what? Yeah. Lovely. Yeah, you remember that I said, I think that I mentioned that this heat, also this heat. Yeah. Alright, moving on. I removed the belt's over there, okay. The tension is over there. This is not mine. It was very convenient that it was here because I used it for the wheel degree. I'm gonna put at the end back again in place. Alright, moving on, stepping it off, removing the cylinder head. I have the rubber mat here to place the cylinder head on. I just remove the followers, the cam followers, the pockets. Why? Because I'm gonna tilt it and I'm gonna put it here to see the combustion chamber side. I'm keeping this one because I have to throw it. Yeah. I just want to put it sideways to see the surface, to see the combustion chamber, and just to have an eye on the intake and exhaust valves. Let's continue, let's open it. By the way, these studs, you cannot put it like how I put the previous studs, because different diameter down in the block. It's bigger. So this exception. This you cannot put like the normal studs that you can put the cylinder head, you can put your head gasket, the cylinder head, and then you can pass the studs from up. It's not gonna work with that because simply it's bigger down and it's not gonna pass the cylinder head. Makes sense, right? Let's take it apart. You remember the last time with the 2JZ, with the previous one, with the 1/2 inch socket? That, okay, I replaced it, I broke the first one, alright? Now in this case, it looks like that's 9/16. Okay? It looks like that's 9/16, that's how does it looks like. But you need a long 9/16. Alright? I don't have a long 9/16. What I have? I have 14 millimeters. What's the problem with the 14 millimeters? The only problem is that it comes nice tight. This is not a problem, this is a good one, this is always welcome. When it comes nice and tight, the socket inside. The thing is, what it takes, I can tell you what it takes. On the inline 6, when I have so long cylinder head, me personally, I don't know what they're doing the other guys, but me personally what I'm doing, I'm start removing a little bit. I mean, I'm not losing completely the nut in this case, or the bolt, if it has a head bolt. I'm not losing completely this one, completely that one, and then I'm moving on the rest. I'm going graduate, little bit, each nut, until it lifts up nicely. With the same order how you're torquing it down, same thing, in reverse, how I'm taking it apart. And now I have to stick this inside and then unstuck it how many times? Tassos, stop complaining, eh? Leave the phone and start working. That's what I'm gonna do. Cylinder head out. I'm gonna show you a couple of things that I'm screaming years now. I'm saying that when you have the studs like this, in this case you cannot put it from up. Like I said, it's impossible to put the cylinder head and then pass these studs from up, alright? Because it's greater inside of the engine block. But I'm saying that when you put the studs like this, always you're gonna trap some metallic savings between the head gasket and the cylinder head. This is 101, that's what I'm talking about, alright? Second thing, what I see here and I don't like, I see that there is a misalignment and I see the firing entering inside of the chamber here. It has a lip. What I'm talking about, it's clear, to my eyes at least clear. You see that I can see here the sleeve, the cylinder? There is a lip here. I'm talking about here that there is a lip, alright? From this side, there is no lip. It's positive. The ring, it's entering inside of the cylinder. That's not right. And here has plenty of space. That's not right. That's not right. This is not right. it's not aligned properly. It's not correct, this. Then if you come here on the cylinder head, you see another one big mistake, I'll say. I'm gonna show you. Let me get one ring from here. I'm gonna get any. Let's get the number 3. Why not? All right. Oh, come on. This here with the grooves, what you see, it's the cylinder head side, and the flat one, it's the deck. It's the block, all right? So now if I place it on the lines that has here, let's make one comparison to see how it looks like. All right, let's put it exactly as it was, right? It even sits there. It sits there. See where it is. If I remove it, see where's the line. There is 3 lines, 1, 2, 3. There is not a single line. That means this ring here, the 2 lines, they are inside of the combustion chamber, and only the outer line, it's touching here on the cylinder head. Only the outer line. You can actually, when you place it here, it doesn't move because find the groove, you know. So here what you see, it's only, if I have to guess, if I had to guess, if you spray nitros, or you have for racing application like this one, obviously, the first thing we're gonna melt, we're gonna burn the firing, it's gonna be here, or here. Here, yeah, okay, same thing here. Yep, and there is a room between, there is a room, what I mean by that. I'm gonna show you what I mean. If you place it here, if you place the firing, yes, that's where it goes, all right? You see, pay attention, between, there is no gasket, all right? It's the firing with the firing, all right? Let's get also the number 2. Let's get also out the number 2. If you get also the number 2, and you put side by side, oh, come on, find the groove. No, you're not gonna find the groove. Okay, no worries. Let's go on this angle. Not a big deal. Yep, I found the groove. You see that you can go a little bit greater, the firing, to be a bit greater, so to don't be inside the combustion chamber, to don't make a leap, to don't be exposed inside the combustion chamber. That's my point. Also, if you see the head gaskets or any firing, it's not entering inside the combustion chamber. That's my point. This I get from the number 2. It doesn't matter. It's been compressed. It's been used. Yeah. These small details, when it comes the time, you're gonna see that it's gonna make a big difference. These small details, what I'm screaming all the time. When you have a misalignment here, that's not right. This is not right to have a step here. I hope that you understand what I'm saying. Here you have a step, here you don't see nothing, because here you can, yeah, it's entering inside. This, it's supposed to be more to this side. Yeah. And this looks like assembly grease. Why to put assembly grease? No, okay, all right. Me, I'm not putting assembly grease. Some other people, they might put assembly grease. Me, I'm putting oil. I'm not putting. And the cylinders inside, I've seen better days. Yay. Okay, just give me a second. The cylinder head is gonna stay there. I'm not gonna touch it. I have here a couple of washers that when I turned it, it went out, because first you put the washers on the cylinder head with a little bit of grease, and then you put it inside, and then you pass the nut, because after that it's impossible to pass the washer. All right, on these studs, you see the studs, right? So, yeah, leave the cylinder head where it is. Then, let me see, because from the top dead center finder, I make this one on the A. I make one small dot. This is not gonna affect nothing, obviously, okay? It's not a big deal. I don't like the cylinders, how they looks like. Usually in these applications you don't make a cross hatch, but again it might backfire to you from the point. Yeah, it all depends on the application. There is no visible cross hatch. If there is, it might be, and there is also some dots on the cylinders. Yeah, this is, yeah, you don't feel it, but okay. Let me remove the gasket and put also the fire rings in order and continue. You know what I see here? I see that there is a room to shift it this way. And if there is a 0.5 millimeter bigger fire ring, I'm talking about this one, you can be always welcome. And you can massage a little bit the head gasket to go that way, because again, even here there is no good alignment. Alright, let's take it off. Let me remove it. I'm removing the studs and I'm wondering what I'm wondering. Yeah, first of all, you can see a shadow here at this point, and you can see a shadow here at this point. And it's not the same. I mean, here it has much more, it steps much more. Here it steps less. And on the cylinder head, what kind of alignment they have done? I mean, if it was equal, let us say, you know, this is the outer line. That's the outer one. The two entering inside. And here you see 1, 2, and almost the third one, the inner. Here you see only the two. Yeah. Has to do the position of the studs, has to do the position of the sleeves, how it's been machined. And definitely if there is a 0.5 millimeter greater, I think, yeah, you have here, you might have 2 millimeters here actually. To make 1 millimeter greater, to don't end up inside of the combustion chamber. That's my point. And what about the alignment after that? Okay, let me continue removing the studs. Not any measurement yet, I just remove the studs, alright? I get the fire ring, and if you align it, it's leaving at least 1 millimeter. So the diameter of the fire ring, it's supposed to be fine. Just only the problem is the misalignment. Okay. So let's put it back in there. Then it turns a little bit tight for this application. It doesn't spin. It's supposed to spin more freely. And I can hear also the piston rings. Even though it does have a cross hatch, it's barely. It's supposed to be nice and smooth. It's supposed to don't hear nothing actually. Okay, I'm not gonna continue today. Actually, tomorrow I'm gonna continue. I will gonna remove the water pump and a couple of other stuff, but tomorrow the rest. Now I feel like that I have 3 hours video, and I might put all the clips together and to be less than 10 minutes. We're gonna find out. The rest will gonna be tomorrow, not today. Thank you.